Lesson 1-4B is going to be subtracting integers. Make sure you've done this after the adding integers, otherwise this one's going to be a little tougher. When it comes to the four basic operations that we use with integers, add, subtract, multiply, or divide, a lot of students have a little bit more trouble with subtraction. Doesn't mean it can't be done, just means we have to think things through a little bit. This very first sentence here, to subtract an integer, add its opposite, this part, that's the thing you really got to remember to do. And notice that it's in two things. We're going to change to addition. We're going to take the opposite of that second number. Now what we do not do is change the first number in the problem, which is what I mean by don't rewrite that first number. So in example A, we are going to not change the first number, it's 12. Subtraction becomes addition. We have to change this negative 15 to a positive 15. Now we're adding two positive integers, 12 and 15. Our answer is positive 27. In example B, 8 does not change. Subtraction becomes addition. The negative 4 becomes 4 because we are now adding the opposite of that second number. Now I'm adding positive 8 and positive 4. My answer will be 12. Some students don't necessarily like to rewrite, and if you can kind of figure out what you're doing, it's not such a bad idea. It'll help later on down the road with some things that we're doing. You can actually make the changes that you want to make by using what I call exaggeration. We're going to change the subtraction to addition, and notice how I really make a pretty big line there. Now remember that I still have to take the opposite of the next number, so again I exaggerate that I'm changing that to a positive. Some students will actually put the cross piece in as well. In this case, I'm going back to the rules that we learned with adding integers. I have a negative integer plus a positive integer. I take their absolute values, 23 and 11. I subtract them and get 12. Now, the negative 23 has the greater absolute value, and since it is negative, my answer has to be negative. In D, we add the opposite. We had a positive 60 there, we need to make it a negative 60. Now I'm adding two negative integers, so my answer will be negative 200. If you want to try these last two, hit pause, and then I will put on the correct answers. Okay, we're going to add the opposite. So our answer is going to be negative 36. Now in F, we're going to add the opposite. The negative 18 has the bigger absolute value, so my answer is negative, and 18 minus 6 is 12. So my answer is negative 12. All right, guess what? Expressions. You knew this was coming, right? Again, I substitute. Negative 4 minus 6. But here, I'm going to add the opposite. Or if I want to rewrite, I can do that. But I've got negative 10. Negative 4 minus 2. I'm going to add the opposite, so my answer is going to be negative 6. If you want to do these last two, hit pause, and then after you've done them, you can come back to the lesson and I'll show you how they work out. Okay, substituting 12 minus. Here's where you got to be careful, because this time, remember, n is negative 4. Now I can do the changing. Add the opposite. And I will end up with a value of 16. The last one is pretty similar. Negative 13 minus negative 4. I'm going to add the opposite, and I will get a negative 9. In addition to subtracting, we're also going to cover what's known as like terms. Like terms refers to terms that are alike. They have the same makeup, and they use the same powers. So for example, if I have an x, a 4x, and a negative 8x, those are all like terms. The coefficients, remember this is the coefficient, really doesn't matter as much as the variable and its power. In this case, x to the first. In B, y, 5y, and negative 2y are considered like terms with one another, but they are different from the x terms. We can't add an x and a y, for example. The classic thing that algebra teachers usually talk about is you can't add apples to oranges. Even if you do get fruit salad, you're still going to taste the apple, you're still going to taste the orange. In C, we can use powers. X squared, 4x squared, negative 3x squared. Those are going to be like terms because they are similar power, but they are not going to be the same as an x or a y. They're going to be different from those. Any integer that you have, such as a 6, a 10, or a negative 15, those are also considered like terms, but are different from any terms that have variables. Now just remember that any letter of the alphabet can be used as a variable. It isn't just always going to be x and y, so you can use a k, a m, a z, and a. I told you once before, we usually stay away from the O because it looks too much like a 0. And we stay away from a small case L unless we're going to use cursive. We don't usually use an L, we use the cursive. And a lot of students just stay away from it. We don't usually use capital letters for variables. Usually capital letters will stand for something like a capital A stands for area, or a capital P stands for perimeter. A capital L stands for liter. So we usually stay away from capitals. What we can do, and what we're going to do in F, G, and H, is we can simplify using these like terms. In F, it's like I have 6 x's. And then the second part of the problem says take 4 of those away. What do you have left? 2 x's. So really, when it says 6x minus 4x, I can just work with the coefficients, and I can just say to myself, oh, I've got 6 minus 4, that's 2, and then I put it in front of the x. That's kind of an easy way to think about it. But really what you have is the representation I showed you, where you have 6 x's, you take away 4 x's, you're going to have 2 left. Now in example G, you'll note here that you've got 2 different terms. This is one set of terms right here. And usually we do deal with variables before we deal with integers, or sometimes they're called constants. So what we're going to deal with is 3y minus 7y first. We add the opposite. That means we are going to have negative 4y. Because if we had 7 negative y's, 3 y's would cancel that out. We would have 4 negative y's left. Now, the 3 and the 5 are integers, so they are like terms. And here is the symbol, the operation symbol that we have to pay attention to. 3 plus 5. So 3 plus 5 is 8. Notice that we generally will write it as a negative 4y. We put that variable first. There's no hard and fast rule about it, it's just that's the way we usually do it. If you want to try h, hit pause, and then I'll show you how it's done. Okay, a little more challenging. First, I'm going to take these two together. Negative 6m plus 2m. That will be negative 4m. Now, I'm going to pull out the other terms. I have a positive 7 plus a positive 2 minus a 9. So what I really have is 7 plus 2 minus 9. Add the opposite. So 7 plus 2 is 9, plus negative 9 ends up being 0, and I don't even have to write that. We do not usually write something like negative 4m plus 0. We usually don't do that. We do it this way instead. We drop the constant or the integer in this case. And that concludes this lesson today.